Hello again. Thanks for stopping by. I'm sure you just watched our light-dependent reaction video. So now we are going to do our Calvin cycle. So our Calvin cycle is also known as light-independent, but I'm going to call it Calvin cycle. So stage 2 of photosynthesis, and this is the last stage. So what we're going to take is we're now going to take our carbon dioxide. We're going to take our energy-carrying molecules from the light-dependent reactions, ATP and NADPH, and we are finally going to make glucose. So if you remember at the beginning, we started with light, water, and now we're adding carbon dioxide, and now we're making glucose. Okay? And oxygen was also a product, but that was exited during the light-dependent reactions. So we are finally making glucose. So I'm going to erase this up here, but make sure you put this at the top of your page. So stage 2 Calvin cycle, CO2 plus ATP plus NADPH equals glucose. Put that at the top of your page. If you haven't already got a new page from your light-dependent reactions, make sure you do that. Okay? So make sure you have a whole new page for the Calvin cycle. By the end of it, it's going to look like this. So follow along. This picture is in the notes as well. So if you can't read my writing as I'm writing on this paper, make sure you go back to that picture. That picture is in the notes. So I'm going to erase this so I have more room to draw out the cycle. All right, so let's figure out what we start with. So within the Calvin cycle, we are actually going to start with each of these circles, whenever I draw a circle, it's going to be a carbon. It's a carbon molecule. So we are starting with 3 5-carbon molecules. So we have 5 carbons, but now we have 3 of those molecules. Our carbon dioxide is going to come in, so we have 3 carbon dioxide molecules. It is going to give that carbon to this 5-carbon molecule. So I'm going to draw that in a different color. It's going to add on So if that carbon dioxide gives a carbon to each of those molecules, it's going to become a 6-carbon molecule. So now we have 3 6-carbon molecules. So step 1, let's write that. So I'm just going to write 1. Step 1. Okay. CO2 enters the cycle. The C from, and I told you my writing is terrible on this, so feel free to look at the picture when you're writing this. But carbon from the CO2 bonds to a 5-carbon molecule to make a 6-carbon molecule. That is step 1. Okay, that's it. So now what happens? Okay. We are going to transform these 3 carbon molecules into 6 3-carbon molecules. Okay, so that's just math. So 3 6-carbon molecules is going to be 18 carbons, right? Yep. And so we're going to transform them into 6 3-carbon molecules. So we still have 18 carbons. They're just in different forms now. So what I would do is I would draw out all 6 to make this easier, but it's going to take up way too much room and way too much time. So that's why I put a 6 in front. So just know that we have 6 3-carbon molecules. So 6 3-carbon molecules. Now, how did that happen? How did we go from a 6-carbon molecule to a 3-carbon molecule? Well, that's when our energy carriers come into play. So we have our, every time I tell you. we have our ATP. Let's fix this again. So our ATP, so that is energy carrying, right? So we are going to use that energy, and that ATP is going to then transfer into an ADP. It's going to lose a phosphate. So it comes from triphosphate to diphosphate. It's going to lose a phosphate. We also have NADPH. That is going to, its energy is going to be used, and it's going to transform into NADP+. So my writing is terrible. Those two molecules are going to go back to the light-dependent reactions. They're going to be reused in the light-dependent reactions. So don't forget that. Okay. So step 2, let's write that out. Okay. So energy is added. Okay. And that is going to equal the 6-carbon molecule splitting into a 3-carbon molecule. So again, writing's really messy. Go to the notes if you want some cleaner writing. So what happens now? So step 3. One of those high energy 3-carbon molecules is actually going to leave the cycle now. So we'll draw on that. So one of those 3-carbon molecules. Okay, so the rest of those, so we have 5 3-carbon molecules down here. Okay, so 6 minus 1 is 5. So we have one of those 3-carbon molecules. It is going to leave the cycle. However, glucose needs 6 carbons. So what is out here waiting for it? Well, look at that. It's another 3-carbon molecule. So those two are going to bond, and that is going to create glucose. Okay, so how many turns do you think this Calvin cycle needs to do in order to get a glucose molecule? Okay, if you said 1, you're wrong. If you said 2, you're correct. Because only one 3-carbon molecule is leaving at a time. So if there is one waiting out here for it, it's going to bond and make glucose. If there's not a 3-carbon molecule out here waiting, it has to wait for the cycle to go all over again to find its partner. Okay, so step 3. A high-energy 3-carbon molecule is going to exit for every turn of the Calvin cycle. 2 are going to bond to form glucose. So that's also in this picture right here, but I don't have enough room. Oh, there's my dogs. I don't have enough room to write that. So I'm going to let you write it on your paper. So step 4. Okay, what's going to happen to these other 5 3-carbon molecules? Because they weren't used for anything. Well, they are actually going to be recycled. So they're going to be kind of turned around. They're going to be transformed back into that 6-carbon molecule. So then we're going to have 5-carbon molecule. So this is going to be recycled. And that is step 4. So step 4 is those 5 3-carbon molecules being recycled into 3 5-carbon molecules. And then these 5-carbon molecules are just going to start the cycle over again. They're going to wait for carbon dioxide to come give them a carbon, and they're going to go through the cycle again. So it is going to be recycled. It's going to stay in the Calvin cycle. However, in order for molecules to be rearranged, what do we need? We need energy. So we have another ATP. So we have another ATP being used up. Okay, takes a phosphate off, makes energy, and now it's ADP. Okay, that allows the 5,3 carbons to be rearranged into 3,5 carbons. That ADP, where do you think it's going? Back to the light-dependent reactions. Okay. So that is the Calvin cycle in a nutshell. Again, it's really messy, so please go look at this picture again. Make sure you have everything. Watch the video again if you're unsure. There's lots of numbers, so make sure you are writing them down, comprehending them. If you have any questions, please let me know. Thanks for watching, and hopefully you'll do really well on the quiz and test. All right.